In this video, I'm going to show you how to use SOHCAHTOA in order to figure out different parts of the triangle. You can think of it like a big puzzle. If you've got an angle and a side, you can figure out most other things. If you've got sides, you can get angles. This is what we're going to use basically when we're breaking down vectors and we're trying to figure out the angle that something's traveling at, all that sort of stuff. Alright, so let me draw a basic right triangle for you. Okay, so we've got a right triangle, and we know, let's say for example, that this side is 40 degrees. Okay, and let's say they also tell us in the problem this side is 20 meters. Based on this information, you can figure out everything else in the rest of this triangle. Oh, one more thing I got to give you. That's a right angle right there. And our triangles are going to have right angles. That's the way we work. So you can figure out how big this side is. You can figure out how big this side is. You can figure out what this angle in there is. All that different sort of stuff you can figure out using SOHCAHTOA. SOHCAHTOA stands for sine is opposite over hypotenuse. I think I spelled hypotenuse right. Could be wrong. Cosine is adjacent over hypotenuse. Going with my original, probably terrible spelling. And tangent is opposite over adjacent. Okay? SOHCAHTOA. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. Alright, and we can use this to figure out the rest of this stuff. So, for example, if I said, let's say I wanted to start with cosine. I could say that the cosine of 40 degrees is adjacent over the hypotenuse. Here's my 40 degrees. Okay, which one of these is the hypotenuse? This guy here is the hypotenuse. So it's going to be over top of 20. What is adjacent to the 40 degrees? This one down here is adjacent to the 40 degrees. Okay, and I'll just leave that as an A, because that's what I'm looking for. Call it an X, you call it whatever you like. Alright, to solve this, I've got to figure out what the cosine of 40 is, and then multiply both sides by 20. Alright, let me grab a calculator. Alright, cosine of 40 degrees is 0.77. 0.77 equals A over 20. Got to multiply both sides by 20 to get rid of that 20. Hold on. Let me make sure that I'm in degrees. Yeah, I'm in degrees. Cosine 40 times 20. I got 15.32. What will my units be? Well, this side's in meters, so that side's going to be in meters, and that side's going to be in meters. So I got 15.32 meters. Alright, there's a couple ways I could approach this side over here. I could use the Pythagorean theorem. I could say 20 squared equals 15.32 squared plus whatever that is squared. Or I could do SOHCAHTOA again. Since I called this thing SOHCAHTOA, I'm going to do SOHCAHTOA again. So what are the two things that I have? I've got adjacent I've got hypotenuse. I'm looking for opposite. So I need something that has opposite in it. I could choose sine or I could choose tangent. Either way, I'm going to get the same answer. I choose sine. The sine of 40 degrees is opposite. That's what I'm looking for, so I'll leave it as an O, over the hypotenuse, over 20. Grab my calculator, and once again, make sure your calculator's in degrees. That's what I was checking before. Sine of 40 equals, I got 0.64 equals opposite over 20. So I multiply by 20, and I get 12.86. So the opposite is 12.86. So I can plug that in here. 12.86 meters. All right, now, in order to find an angle, there's a couple ways I could do this. I know all the angles in the triangle add up to 180. So I could say 40 plus 90 is 130, and that guy has to be 50 degrees, so that's what it's going to take to make it 180. That's one way I can do it. Or, once again, I could use SOHCAHTOA. I'm going to use SOHCAHTOA so you can see how to find an angle. All right, because I've got all the sides, I can pick sine, cosine, or tangent and have everything I need. When I'm in that situation, I usually pick sine. So I would say that the sine of theta, that's just an unknown angle, sine is opposite over hypotenuse. So now I'm working with this angle. The opposite is 15.32 over the hypotenuse is 20. So 15.32 divided by 20 is 0.77. 0.77 equals the sine of theta. Now if I want to get theta, I need to do the inverse sine operation. On your calculator, that would be a button that looks like that. Looks like sine to the -1. Right? Or it might be a function that looks like sine to the -1. So what you do is you type in 0.77, and then you hit that button. Or you would hit that function for 0.77. So the inverse sine, 0.77, this is going to give us the angle, is 50 degrees. 50.3 because I rounded actually. But 50 degrees. So up here we can erase this guy, and we can say that it is 50 degrees. Now, how can we check our work to see that we figured everything out for this? We can look at making sure all the angles add up to 180. 90 plus 90 equals 180. We can use the Pythagorean theorem and make sure it works out. If I do 15.32 squared plus 12.86 squared, that should be equal to 20 squared. Let's see if it works out. 20 squared, 400. I really should have just done that in my head. 15.32 squared, 234.7 plus 12.86 squared, 165.4. If you add those two together, 2, 3, 4, 7, you get 400 and some decimal. Very small decimal. Okay, get that decimal just because of rounding. But 400 equals 400. Look at that, math works. Okay, so using SOHCAHTOA, you should be able to figure out everything you don't know in a triangle just from a side and an angle. So I'm going to draw one up here that I want you to try, and you can try that on your own. Okay, make sure you check your work after you're done, and you'll know if you got it right. All right, so let me erase this. Nice thing about video is I guess you folks can just pause it if you want me to keep something up on the board. Okay, so here's another triangle. That side's going to be 90 degrees. This side we're going to say is 35 degrees for that angle. And we'll say that this side is 12 meters. Okay, based on this, I want you to find, using SOHCAHTOA, the length of this side, the length of this side, and what that angle is. Think you can do it? I hope so.